short lecture on 8051 microcontroller architecture, or we can say the introduction to 8051 microcontroller architecture. And just in short, introducing about the 8051 microcontroller. It is actually it is introduced by Intel in 1980, and it is known for its integrated CPU, RAM, ROM, IO ports, timer, serial port on the single chip. And that was the new thing there, that everything was coming on the single chip compared to the microprocessors of those days, 8085 and 8086. Those were the microprocessor at that time, and this microcontroller was having all these things together, which is very much useful for building the application directly. And at that time also, not that time, even now also, it is used, popularly used. And even one important thing is for the syllabus of engineering generally, this microcontroller is generally taught, and the reason was to understand the basic architecture of the microcontroller, and all the remaining architectures of the advanced microcontroller, they are what we can say the further version, the advancement in this microcontroller. So once we understand the architecture of this 8051, it is easy for us to think about the other architectures. Now, why to think of the architecture, or why to understand the architecture, that is also one of the thing. And the reason is, when some machine or computer has to be used efficiently, what is required is to use its all capabilities. And for using its all capability, it is required that we know all its functionality. And that's why studying the architecture at first before going to the programming, because nowadays it is very easy that directly we are going for the programming and doing the programming, but at that time we are not efficiently utilizing that microcontroller, and that is a reason we have to understand the architecture. So in short, starting with my presentation, I'm not going to next slide. Yes. So this MCS 51 by Intel, it is also called as MCS 51. Even many versions are there for this architecture. And talking at first, giving the overview of this MCS 51 architecture, at first we have to understand, as given on my slide, on this right hand side, this single chip microcontroller. This is how the microcontroller is there. On one chip, everything: CPU, RAM, ROM, that is central processing unit, random access memory, which is used for data, read only memory, which is used for programming, IO ports, which are helpful for connecting with the outside interface, timer for setting the timing, internal timings, and the serial communication port, all are coming on the single chip. Whereas on the other side, if we compare it with microprocessor, which is CPU, main thing is CPU, general purpose microprocessor is central processing unit, whereas it is what is required in that case, that everything, your program memory, your data memory, IO ports, has to be externally connected, and you have to make a machine. And obviously it is used for wide applications compared to the single chip microcontroller, but that is main difference. So what we can say here is, when we have the specific application, we are going for specific application, at that time microcontroller is the important thing compared to the microprocessor. That is how we have to go further. So from what point of view we are looking toward the microcontroller, it is required for the specific application. For example, let me take the example of washing machine. There I want some specific things to be done to check the inlet, water is coming or not, power is on or not, door is closed or not. So few things I have to check. On that basis, I have to start my washing machine for the particular time which has been set by the timer. I have to make it work and then to complete it. So the specific application is there. So that type of application, whatever we are thinking around us, the applications are there. There we are using, or it has been used, microcontrollers have been used. Okay, so This slide is trying to show the difference of the diagram of microcontroller and microprocessor. Further, I would like to add that hardware, it is interface to the real world. Okay, whatever it is, microcontroller, microprocessor, its hardware is available for interfacing with the real world, and the software, what it is doing in both the cases, it is order how to deal with the input. It is giving the sequence how we have to deal with different input. As I have given the example of washing machine, at first we have to check power, obviously door is closed or not. Then if yes, we have to check if detergent is there or not, and then to start with that way, inputs, different inputs in sequence we are checking, and that has been fed by whom? By the software. Where it is, that software is in our ROM, and that is how our microcontroller is going to work. I'll go further. It is just the overview. Obviously, we have to go to the architecture in detail now. Before going to the architecture, even we must know what is the architecture used by our microcontroller. Okay. Again, as I told you, it is to increase the efficiency, or how many data bit we are dealing with, what is the bandwidth of that microcontroller. For finding out that, we must know that which architecture. So basically two types of basic architectures are there. One is von Neumann, another one is Harvard architecture. We are not going to go in detail with this, but 8051 is going by Harvard architecture. Some of the version of 8051, they are using von Neumann architecture also. I think ARM is also using von Neumann architecture, but 8051 is going by Harvard architecture. And what that Harvard architecture is specifying, look at the second diagram. The data memory and program memory are separate. As we have seen in the previous diagram, ROM and RAM were separate. Is it right? So, in similar manner, data memory, that is RAM, and program memory, that is ROM, is separate. And what you can think of now? That the bandwidth which is dealing with the program memory and the bandwidth which is dealing with the data memory, they are separate, and thus we have the chance of keeping what band is there. So look, in case of 8051, 8-bit bandwidth of data memory is there, whereas 16-bit is for program memory. Means the instructions are of 16-bit, whereas the data which we are fetching is 8-bit. As we know that 8051 is the 8-bit microcontroller. So how many bit of data it is dealing with? 8-bit. So that bandwidth separability is there, and obviously the system is fast compared to this above system. What this above system is doing? On the same bandwidth, it is fetching the program as well as data. So comparatively, the Harvard architecture, we can say it is fast as well as improved bandwidth is there. That is only the thing we want to take from here about the bandwidth. We'll go further. So I'll not go for this comparison of 80. These are the derivation of 8051 family, 8051, 52 and 31, and they are differing on RAM, ROM, timer, IO, serial and interrupt. I'll go straight to the architecture. I'll not wait here. Okay, so before going to the architecture of 8051, at first we will check for the block diagram of 8051 so that it will be clear. So in the second slide, first or second slide, I have shown you in one box. There is CPU, there is ROM, RAM, timer, serial port, everything what's there. Okay, and now look here, the block diagram is keeping or it is showing the distributed way how the connections are there for those RAM, ROM, CPU and so on. So here the green, this green flowing bus, this is the bus for us. Okay, you can call it as the address or data bus. So this bus is connected to CPU from all these blocks. Sometimes it is both directional as well as in some cases it is single directional. Okay, so this is our CPU, that is central processing unit. You can call it ALU also, that is arithmetic logic unit, where all arithmetic and logic operations are happening. Our 8051 is 8-bit microcontroller. Okay, so 8-bit and 8-bit, that type of operations are happening here. And as you know, all logical operation means ending, oring, and so on. And arithmetic operations means addition, subtraction, even multiplication. That one facility is there in 8051. So 8-bit by 8-bit multiplication, that facility is also available. So these types of operations are happening here. Okay, so this is ALU. In architecture, we'll go in further detail, but at presently try to understand CPU is having what? ALU, arithmetic logic unit. Further, you can stop these operations somewhere in between due to interrupts. Okay, so these are interrupts: interrupt 0, interrupt 1, TF0, TF1. Later on, we'll go in detail with TF0, TF1, T1 by R1. So these interrupts, as I'm taking the name, these are interrupt, and these interrupt can stop the operation, whatever is happening in ALU, depending on their priority. Okay, if they are having the priority, they can stop it. If they are not having that much priority, work will go on. After completion of that work, then it will be stopped like that. Similarly, this CPU is given what? One oscillator or the clock frequency has been given to you. So this is the arrangement, a crystal to capacitor. That is the arrangement of our oscillator. 11.0592 megahertz is the frequency which we are supplying to the ALU for working. This is oscillator frequency. Okay, further we'll go in detail, but at present, nearly approximately how much? 12 megahertz is the frequency given to CPU, so that the CPU will work with that oscillator frequency. In conjunction with, in synchronization with this oscillation, it has to work, right? Okay, so these are the three blocks we are talking about. Now, the CPU is working on some instruction. Obviously, who will give the instruction? This program memory. ROM is the program memory. How much is the program memory in case of 8051? 4 kilobyte is the program memory. 8-bit is the width, and what is the height of 4 kilobyte? That much means 4096. 4 kilobyte means what? 4096. 4 kilobyte accordingly. So that height will be there, whereas width is of 8-bit, that much ROM. Those many instructions you can store here. So those instructions, our CPU, they are working on those instructions. Okay. Now, the instructions which we are taking from here, from the ROM, whatever data is required by that instruction, from where we are fetching it? We are fetching it from the data memory. How much is the data memory? 128 byte. Why I am saying byte? Because my microcontroller is 8-bit microcontroller, and 8-bit means what? 1 byte. Again, how much is the width of this RAM? 8-bit is the width. And how much is the height? 128 byte is the height of my RAM. Those much data I can store here. We'll talk about it again in detail. So that way the program memory and the data memory is there with the CPU. So while fetching the instructions one by one, ROM will take help of this RAM, means data will be taken from here, instruction will be taken from here. One by one, it's decoding, and then fetching, decoding will happen, execution and storing. All the things will happen here with help of the CPU. Further, what is there? 2 timers are there for setting the time. I'll keep my example same. My my washing machine. So what I'm doing is setting the time in it. So what I'm doing is setting some timer with help of this clock frequency. What I can do is, using this clock frequency, I can decide, I can set the time in one of the timer, maybe timer 0, timer 1. If one more timing I have to set, I can use timer 1. That way I'm setting the timing, and it will help my CPU to execute that particular operation. Other than that, bus control, controlling the IO port, IO bus, controlling the port. For that, bus control logic or bus control hardware is available here. Further, there are 4 IO ports for connecting with external devices. These 4 IOs are there. When we are when my microcontroller have to connect with the external things for controlling, as I say, washing machine, its door, then maybe the water pump where to stop it. That way the IOs are there. So how many ports are there? 1, 2, 3 and 4 ports are there. And each port is of 8-bit. Okay. And the CPU, after execution, it can give instruction to those ports. We are programming the port as either input port or output port. And accordingly, either we can take a signal from the port and can give the output to the port. So that way, 4 IO ports are there. Along with this, one more important functionality which is there in 8051 is serial port for serial communication, for universal asynchronous transmitter receiver, that is USART. You can, that serial port, serial communication can happen in 8051, and for that this writing and reading, those two pins are available. That way the block diagram is there, and now you can think of how many different thing we can do, different application we can execute with help of this 8051. Okay, so going further, expecting I'm audible properly. Okay, someone is asking me to show the previous slide. I'll go there. I have not checked the message once. Which one? Second. This? Yes. Are you talking about these classes? Sorry, this slide? Yes, ma'am. First 3 slides. Okay. What I have to do with them? Ma'am, is bus control block for controlling only external port that are connected to IO port, or does bus control block also control the main bus? Green color. Okay, let me check what you are talking about. Bus is in the block diagram. Any question about this slide? Then I'll go to the next one.
Yes, ma'am. Ma'am, can you give the examples for von Neumann architecture?
Von Neumann architecture, yes. Actually, ARM architecture, ARM microcontroller, ARM controller is one of the controller using von Neumann architecture. Okay, a version of ARM, I think ARM 4 is there, which is using the von Neumann architecture. Okay, and what else you were asking about? Okay, someone is asking again to explain first 3 slide. I missed it before. May I explain it again? Just in short, we'll talk about, not much, you have not missed much. So I was talking about 8051 microcontroller, and what I am telling here is this diagram. You can see my cursor. This is the microprocessor architecture. What is there generally? There on the chip, there is only general purpose microprocessor, means CPU, that is central processing unit. Okay, and all these things, what RAM, ROM, IO port, timer, serial IOs, all these are external components to be connected to your CPU so that you can increase the functionalities of your CPU. You can even add more components. So these are all externally connected things. Okay, that is how microprocessor used to be. Microprocessor is generally for general purpose use. Sometime I need Excel, I can put Excel on it, I can use it. Sometime I need to do some signal processing, I am installing that software using for it, and so on. So what? A very general purpose use. At that time, microprocessor can be used as we use our laptop, right? Laptop is having whatever controller, not controller, processor is there, Intel processor inside. So that processor is what? Microprocessor. And all RAM, ROM are externally connected to it to increase its functionality. Whereas what is microcontroller? Your microcontroller is all these things on one chip, but it is used for what? Specific applications, right? It has limitation and it can be used for specific application. So what we need for those application? We need obviously the processing unit, but that processing unit will be having some limitation. Do you know in our laptop generally nowadays how many bit laptop it is? It is dealing with how many bit? Maybe 32 or even more than 32, 64 bit by 2 to the power. It is increasing, right? Whereas microcontroller, I'm talking about 8051, it is just 8-bit microcontroller because we are limiting the functionality. We don't need those many bits, 32-bit at a time. We need what? Limited bits to be worked on. So CPU, it is there on the chip. RAM, ROM, that is RAM is random access memory, means the data memory. Read only memory means this is program memory. Here we store the program. We don't have to change the program, and that's why this is read only memory. IO port connectivity or IO ports, then timer, serial communication port, all these things are coming on the single chip. Okay, so that is how microcontroller is there. In the second slide, just I told you about the von Neumann and Howard architecture. And here what I was trying to tell you, we have to reach up to what? Architecture. I was trying to tell you that Howard architecture has, look, this is the program memory and this is data memory. They are separate. Program memory and data memory are separate. In which? In Howard architecture. And by this 8-bit bus, we are communicating with data memory, and by this 16-bit bus, we are communicating with program memory. So this bandwidth as well as separately this bandwidth. So separate bandwidths are there for communicating with data and program memory. So this work, obviously, you can think it will be faster. Is it right? It will be faster. At a time, both are working. Whereas in Howard, what is happening? The single 8-bit bus is there. At first, it has to take the program. That program will be decoded. When that program is saying that from the particular location, we need the data, again, it will go and fetch the data. Okay, so that is again the limitation, as well as this bandwidth, which is of 8-bit, instructions also of 8-bit, and data is also of 8-bit. So that limitation is coming out there in von Neumann architecture. Okay, so ours 8051, which we are going to learn, is this Howard architecture, and we can identify it from here because your program and data memory, they are separate. Okay, I particularly skip these 2 slides. This is just my introductory lecture. Later on, whenever it will be required, I'll be going in much detail. Here, I exactly don't know who is in front of me. Those are the students or judges. I don't know. That's why by some different mean, I'm going to take this lecture. Okay. And then I explain this block diagram. Let me check the chat. Acha, someone is asking me what is considered as on chip and what is off chip. If you check for 8051 microcontroller, it is a single chip, and on that same chip, everything is there, whatever I have shown you in that block. That is called as on chip. Off chip means my chip is there and separately I
Ma'am,
have to, yes,
ma'am,
yes,
chip and IC are same or different?
yes, they are same, they are same. Chip means IC. Chip
Okay,
means
ma'am.
IC. Huh? So separate chip when I have to take and I have to make the connectivity, then it is off chip. Okay. In our laptop, what we have? We have off chip memory. On your processor, memory is not there. On the chip of processor, memory is not there. It is separately connected. That is off chip. Okay. And on chip means it is there on the chip. Okay. Any else question is there? So here again, someone has confusion of on chip and off chip. Okay, I'll go back there. Don't confuse on it. Look, all the thing on single chip, single IC means on chip. All these are on chip. In this case, what is there on the chip? The CPU is on one chip and remaining separate chip, 1, 2, 3, 4, 5, all separate chips, they have to be connected. Now clear?
Yes, ma'am.
Okay, I'll go further. Is this block diagram okay? Do you understood what I am trying to tell through this block diagram? All these things are on one chip. What is there outside? These pins are coming outside. Int 0, int 1, T0, T1, TXD, RXD, port pin, oscillator pin. These pin are coming out of that IC or chip. IC and chip is same thing. And all the things with this internal connectivity of buses, it is there. Is it okay? May I go to the next slide? I think someone has here what is considered as on chip, what is off chip. I think I answered this one. Na? Okay. Right. Good. You understood it. You have given the answer. Okay. So this is what I explained to you. These are the features of 8051. 8051 is what? 8-bit processor. Means it is dealing with what? 8-bit data. Okay. How many bit it is dealing with? Only 8-bit at a time or 1 byte. What do you mean by 8-bit? Means 1 byte. The CPU can work only 8-bit of data at a time. If data is larger than 8-bit, what will happen? It will be broken into 8-bit pieces to be processed by CPU. Clear? Okay, so that way we have to work with the data. Your CPU, it is 8-bit. As we are saying, microcontroller is 8-bit working on 8-bit data. My CPU is of 8-bit. Okay, and with the CPU, there are some register helping it. One is register B, and then register R0 to R7. These 8 registers. This A is accumulator and B is the supporting register. These two registers are working in conjunction with directly in conjunction with your CPU. Whatever data you have to work on, where you have to bring? To this accumulator you have to bring. Okay, for example, I have two 8-bit datas, right? Two datas, both of them are what? 8 bits. So one piece of 8-bit data will come to A, other piece of 8-bit data will come to B. And then whatever addition operation is there, it will happen inside the CPU and the result will be stored back to accumulator. Okay. Till then, the remaining data which I have to work on, I can store in this register bank. This is register bank of how many registers? 8 registers. In that register bank, I can store my data. I can take it from there whenever required. My instruction will take it. My program will take it. And it will bring where? To the A, to the B operation, wherever the operation will happen inside the CPU. And the result, where it will be stored? In A, the result will be stored. Okay, then further we have 16-bit program counter. One register is there, but keep in mind previous registers, they were of 8-bit. And what about the program counter? This is counting the sequence of your program. It is counting your program, what is executed next and next, it will go on counting. So it is a 16-bit program counter. But as we are saying, we have everything in 8-bit, means program counter has two part, 8-bit, 8-bit part. That way, we are going to deal with our program counter. Higher 8-bit, lower 8 bits. Okay. And there is one more 16-bit register. It is what? Data pointer. Okay. Data pointer, DPTR. So clear? All remaining are 8-bit register, but only two registers are there, which are of 16-bit. What are those? One is program counter. Second one is data pointer. Okay. Then one more important register is there, which is of 8-bit and it is stack pointer. Okay, why these registers are there, how we are dealing with them, we will check it later on. But at first, we must know the name of these registers. Okay, further, internal read-only memory, it is of 4 kilobyte. Okay, how much? 4 kilobyte. And what I told you, what is mean by 4 kilobyte? 4 kilobyte means 4096. How many locations? 4096 locations. So, 2 to the power, how much is 4096? Can anyone tell me? Can anyone tell me? Try finding out. 4096 means 2 to the power how much?
2 power 64.
64 or 16? Check it. How much is 6? 2 to the power 16 will also be not there. Now, how much? FF. I think 2 to the power 4 and 4, 8. 7F. Okay, okay. I
2
will take
power
it.
12, ma'am.
12, 12. Right. 12. 2 to the power 12. So, keep in mind, 2 to the power 12 is 4096. Okay. So, how many bits will be required to address 4096? 12 bits will be required to address 4096. Is it right? Okay, we'll go at present, just keep that in mind and we'll deal with it later on. So, to address how many? 4096 location, 2 to the power 16. 2 to the power 12 means 12 bits are required to address it. Okay, further. What about the RAM? 128 byte of RAM is required. And again, to address 128 byte, how many bits will be required? For addressing it, you will be requiring 8 bits. How many? 8 bits will be required to address 128 byte. Keep in mind, 8 bits are required here and 12 bits are required in the other cases. So, further, two 16-bit timers are there. We have the timer. I told you why we need the timer. When we have to set the internal timing somewhere. For example, in my mobile, I set the alarm. Okay, maybe I am using, or maybe I'm setting the stopwatch. So at that time, what I'm using the internal timer so that I can set it. So that is how setting the time. Okay, so how many timers we have? Two 16-bit timers are there. These registers we will see in detail later on. One serial port is there. Then we have 32 IO pins. Means how many chances of taking input or giving the output? We have 32. Okay, so for example, few inputs I have to take from the sensors and I have to process on them. Okay, so how many numbers of chance is that I can take the input from 32 sensors? This much interfacing. So try to understand that we can even develop a big application using 8051. As well as, for example, I have to give the output to one LCD, I have to give one output to few LEDs. That also I can do. So how many IOs? They can be input, they can be output. How many? 32. And 32, if I am dividing it by 8, means how many ports? 4 ports are there. We are grouping it. 8-bit port, how many? 4 ports are there. I can separately use every line, as well as I can use grouping of 8 also. Are you getting? So that is how much outputs we have. 32 IO pins are there. Other than that, 6 interrupt sources are there. Why we need the interrupt? Because if some important thing has to be conveyed to the CPU, that stop your working and take care of this external important thing, that is interrupt. So how many interrupts are there? 6 interrupts are there. Okay. Then oscillator and clock circuit. We need this because we want our microcontroller to work with synchronization with of the clock. So That's why we need a clock circuit as well as the oscillator. I have shown you the oscillator. And then 40 pin. How is my IC? It is the 40 pin dual inline package IC on the two side. 20 pin on one side, 20 pin on other side. That way 40 pin DIP chip is my 8051. So this is just the introduction to the 8051 and the block diagram of 8051. This might seems difficult to you. Let me check the messages. Is the instruction memory address of 16 bits, so DPTR is also required to be 16 bit. It is data pointer. We will talk about data pointer, and at this instant talking about data pointer in detail is not possible. That's why I have not told you. I'll tell you what is it. Okay, 2 to the power 12 is right. It is giving you 4096. We'll talk about data pointer. Don't worry. Okay, may I go to this architecture? Till this point, do you understood?
Yes, ma'am.
Okay. Now, this architecture of 8051, again, we will check it, how the architecture is there. And now look, the arithmetic and logic unit is there. Okay, what it is doing? What operations? Arithmetic operation. What do you understand by arithmetic operation? Addition, subtraction, multiplication. These are arithmetic operation. Okay. What do you mean by logic operations? Logic operations means ANDing, ORing, XORing, NOT, and so on. Those are logic operations. So these types of operations are happening in your ALU, that is arithmetic and logic unit. It is supported by what? A and B. What I told you, what are these A and B? A is the accumulator, which is the register. How many bit register? 8-bit register. B is again the 8-bit register, which is the supporting register, storing the other 8-bit of data, which has to be dealt with in this ALU. Is it right? Now, whatever is the output of ALU, whatever you are getting after addition, whatever output you are getting will get saved in A. Okay. Whereas after addition, after that operation, if some changes, if carry is generated, auxiliary carry is generating, overflow is happening, this type of thing will be noted by whom? By the program status word. This is one register which is called as special function register. Okay, what is it? Program status word. It is keeping the status of the program while adding. For example, we have some bit in A, we have some bits in B. Yahan, how many bits are there? 8 bits. How many bits are here? Again, 8 bits that we are adding. While adding, is there carry generated? Then that carry flag will be high in PSW. We have to check that PSW in detail later on. So it is keeping what? Status of what is happening in this unit that has been kept here. We'll go in detail of this PSW. So very clearly, this A or B, either they are taking the data from RAM or from any of the IO data is coming in, right? And the operation is happening on the data on basis of the program which we are getting from here. Okay, program where from where? Program is coming from here. From where data is coming? Maybe from RAM or maybe outside. On my port, I have some data. I have to do the operation on that data. That will be fetched. But who will tell to fetch it? The program which is there in the ROM will tell to fetches. Okay, then PSW. Then here is the special function register. Okay, what is the next thing? I told you about ALU, I told you about A, about B, about PSW. Now the special function registers and RAM. There are some special functions register. We will go in detail for that special function register, and RAM is there, which is saving the data. Presently, it is saving the data which will be required for the program, whatever we are executing. Where will be the program? Where will put the program? In the ROM, we'll put the program. We can't change the program. Obviously, once we are burning the program, that program will be present there. Now, to this program, who is helping? Program counter is helping. It is telling to increment the instruction one by one. We don't want only one instruction to be executed again and again. So it is keeping the track of other instructions. This is data pointer. These two are what? 16-bit register, right? 16-bit registers, and they are pointing towards the data. Okay, further. Now, what are these? These are all ports. How many bit ports? 8-bit port. Port 0, I told you, 32 IOs are there, and they are divided into how many parts? 8 by 4, 32. So, port 0 is of 8-bit, port 1 of 8-bit, 2 of 8-bit, and 3 of 8-bit. 8 4s are 32. Externally, we can take 32 input, or we can give 32 output. Now, these are the ports. They are supported by latch. Why latch? Because whatever is coming in, if it is going from the pin, it should be latched somewhere. It should be saved somewhere. Is it right? For some time, it has to be saved because internally we have to take it, right? So that's why it is supported by the latch. You can give input on it, or you can give output to those ports. So that is the structure. Now, checking for this port, one important thing is, look, this port 0, it is IO port as well as IO port means what? It is the data port as well as address port. It has multiplexing. Your port 0, it is not just IO port, not just data port, it is address port also. Okay. What address we are talking about? If my microcontroller, it needs some extra external memory that I can use by using this address. In 1 minute, one more question is there. In this detailed block figure, where is R0 to R7 located? Yes, I'm going there. Look, this is R0 to, this is register bank 0, 1, 2, 3. And every register bank is made up of 8 register, R0 to R7, R0 to R7, again R0 to R7, again R0 to R7. These many R0 to R7, because we need lot of data, na? That's why all these registers are there. Okay, so I was talking about port. I'll come to the port, then I'll go there. So your port 0 is IO port as well as address port also for the external memory. Port 1 is purely what? IO port. Only for what? Data. Port 2 is IO port as well as higher bit of address. Look now. Now tell me, if I'm saying I can deal with the external memory, how much address bits are there? A15 to A8 means 8 bit here, and A0 to A7 again 8 bit here. How many bits I have? 16 bit I have. And if we have 16 bit 2 to the power 16, that much external memory I can deal with. Can anyone tell me? 2 to the power 16 means how much memory we can deal with? Yes. Can anyone try telling me? 2 to the power 16. Look, how much address bits are there? A0 to A7, 8 bit. A8 to A15 means again 8 bit. 8 plus 8, 16 bits are there for accessing the external memory. So how much external memory I can connect? 2 to the power 16 is the external memory I can connect. How much is 2 to the power 16? I think 64K.
65,536.
Right, means 64K. 64 kilo of external memory we can connect. Okay. So that much external data memory as or program memory, whatever I want, I can connect. Why? Because though that much connection I have. Okay. I'll come to port 3. Port 3 can be used as IO port as well as it can be used for interrupt, it can be used for counter, serial data, read, write. For that work, it can be used. Means these 3 ports, they have multiplexing. because we don't need this much IOs. Are you getting my point? These many IOs, and remaining we are multiplexing so that much functionality can be brought together. This is how your port structure is there. Further, we'll go to this register bank. Okay, or you can call it as what? RAM. This is our RAM. So how is my internal RAM structure? It has 1, 2, 3 and 4 bank of registers. And in every bank, how many registers are there? 8 registers are there. What are their name? R0 to R7. Again R0 to R7. And which bank to be dealt with can be specified in program status word. While programming, I can program 2-bit in my program status word, and they will decide which bank we are selecting. So this is how we have our RAM. After that, upper part of the RAM is bit addressable or byte addressable. Means we can address the single bit of this RAM. If I need just 1 bit from there, I can address it. Or I can go for complete 8-bit, means byte addressable. Okay, what it is called as bit or byte addressable, depending on my requirement. Right? So that is how my internal RAM, part of internal RAM is there. Other part of internal RAM is special function registers. We have to go in detail of special function registers. These are few short name of those special function register. Instead of reading it there, we will go for every special function register in separate, because we need their working. We need their detail, not only the name. We need what 8 bits are there, because we have to program them. Can I consider you understood this diagram after the block diagram? Okay, this one part is remaining. I'll talk about it, but can I consider you people understood it? Right. Question is, for port 0, why do we have D0 to D7 also? Now, look, when I am giving some address of external data or program memory. Okay, so when I have to take the data in, from where to take? From here only I can take that external data in. What I am doing? I am connecting my microcontroller. This much internal memory of RAM or ROM is not sufficient for me. Let it be. RAM is not sufficient for me. I need some external memory to be connected. So how I am connecting? With help of this address, I am connecting it. With help of this address, I'll be addressing at that address of external memory. Some data is there, fetch it. So it will be fetched through these 8 pin and it will come inside. Or whatever data I'm generating here, I can put there. I can save there. So where I'll save? With help of these pin, I will save there on the external memory. That's why I need what? D0 to D7 also. Good question. It was very good question. Okay. Only one block is remaining in this case, and this is the block with some of the pin which are externally available. This is EA bar enable pin, address latch enable, and few pins have been shown here. These are the external pin. In pin diagram, we'll go for those pins, VCC, ground. And what these pins are doing? They are setting system timing. They are talking about interrupt. They are talking about data buffer and memory control. Okay, that is what these external pins are talking about. This is how your microcontroller 8051 microcontroller internal structure is there. And how much we know about this internal structure, we can efficiently use it, right? We can efficiently use it, and we can accordingly program and do the efficient programming. Okay, may I go further? Any question? Any other one has any question? Okay. So though we have checked in block diagram, we will just go through the details. Registers. I talked about the registers. Registers are used to store information temporarily. Where are the register? We have seen bank of registers are there. All are 8-bit register, while the information would be byte of data to be processed or an address pointing to the data to be fetched. That is how we are using the register. Meaning of this, what the registers are saving is the data. Okay, it is saving the data, or it is the address also. Okay, in the register we can save the data or we can save the address. Why the address? That address in program is telling us that on this address whatever is data, go to that data or do some operation with that data. That way the register is saving the data or the address pointing to the data. Okay, for that work registers are used. The vast majority of 8051 registers are 8-bit. There is only one data type, that is 8-bit. Okay, this is about the registers, and most widely used registers are accumulator. Where is this accumulator? It is working in conjunction with what? ALU, right? For arithmetic and logic instruction. Other than that, B. B is also supporting register to the A. And what about this R0 to R7? What I told you, where they are? They are bank of registers. How many bank? 4 bank of registers are there. Again, who is supporting? Data pointer and program counter are supporting to it. That these all are the registers. Look, whatever registers we are talking about, registers are like this. How many? 8-bit. D0 to D7. D7 is the MSB or most significant bit, and D0 is what? Least significant bit. Here you are saving or storing either the data or the address. Again, our address is also of 8-bit, which is pointing to some other data. This is how the register is there. Okay. Do you know the register by the name register? Can you imagine the digital circuit which is there, which is called as register? Do you know? If not, it is homework for you people to find out how is the register. What actually is the circuit of register? It is the digital circuit. Obviously, we are dealing with everything is bit, na? Bit data. So for storing that bit, what exactly the circuitry is there? Try to find it out. It will be much clear to you. So D0 to D7. That way, 8 bits we are dealing with, and this is how 8-bit register is there. Okay. Further, now 8-bit registers. So how is the stack? A, B, R0, R1 up to R7. That way the registers are there. What is the width? 8-bit is the width. And which two are 16-bit register? Program counter and DPTR. Obviously, this is in two part. DPH, data pointer higher 8-bit, data pointer lower 8-bit. So these are just the name I am trying to put in front of you for the registers. Okay. Now, here we are coming for the detail of 8051. RAM of 8051. Do we have to continue or to stop? Let me ask. What you are asking for? I could not catch D0 to D7 point. Can you please mention it again? Okay, for the register you want to say. Okay, once I'll explain it. I'll go to that register. Acha, this you are talking about. Okay. As we say, 8051 is 8-bit microcontroller. It is dealing with how many bit? 8-bit. Its data memory as well as its program memory is having width of how much? 8-bit. Here we are talking about data memory. Its width is how much? 8-bit. Okay. So 8-bit means at a time, how many bits we can say? What is the width? This D0 to D7, 8-bit of data we can save. Okay. If my data is of 16-bit, what I have to do? I have to divide it into two parts. 8-bit at first, and then in above register, I have to save the 8-bit. That is how the registers are there. 8-bit registers are there, and this is the digital structure. Okay, what is this? This is the digital structure made up of maybe D flip-flop or something like that, which is storing 1 bit of data. Okay, one structure is storing how much? 1 bit. So 1, 2, 3, how many bits I can save? 8 bit I can save. This is how the register is there. And which register we are talking about? For example, this accumulator, this B register, and the any register from the bank of register. All these are 8-bit register. Actually, what exactly you don't get, can you again tell me? If you get this, it's okay. Else again tell me. I will try to explain again. Is it clear? I think it is question from Lata. Lata, is it clear to you? Yes, it is same 8-bit acts as data. And address is also of 8-bit because RAM as well as ROM, they have width of 8-bit. That's why address is of 8-bit. Data is also of 8-bit. Right. Okay, good. Let me ask, do I have to continue or stop here?
Yeah. So how much it is over? Like if someone thing is remaining, you can cover.
Actually, 8051 is a very big
Okay.
thing. That's why I'm
Okay,
asking.
then we can stop it. We can stop it. No problem.
Okay, okay, okay. And if
Okay.
you want further to go for a RAM to explain it, I can go for it, no problem. But it is very big thing.
Yeah, no issues, no issues, no issues.
Mhm.
Oh, so thank you so much, ma'am. Thank you everyone for joining. Yeah. So thank you everyone. Thank you, ma'am.
Okay. So may I? Okay, I'm going out. Okay, thank you, participants. Thank you for the response also. You asked the questions also very well, and I think you understood it. Good.